or where it throws exception errors after I reconnect to the same socket.
Okay. And it may be that it's not actually coming from the new connection. It may be remnants of the old connection still kicking around.
Even if you call it closed?
Well, if you don't shut down the old thread, it may still be trying to read from the old socket. And so you type something and hit enter, say on the server side, it may be the old thread that's picking that up.
See, I was getting an exception error and it was because I wasn't closing the print writer.
Yeah.
The problem you had.
And if you don't close it, if you're not going to use it anymore, you don't have to close it. But if you don't close it, whoever else is using that may not notice that it's...
Indeed, that's when it would show up, is when I was trying to like say, like it wouldn't have happened eventually like right off the bat, but if I tried to write, depending on which side it was on, like if it would sometimes do it like on the client side or the server side.
Mm-hmm.
Whenever I tried to write it and send it, that's when it would throw it.
Right, right. Let's
It would probably be easier to demonstrate thanks to my current iteration.
Yeah.
It does look good, however. I can communicate either way, without lockstep.
Okay, good, good. That's the main goal.
I have this weird bug where whoever I connect to talk to is really mean to me.
Currently, my client also looks better than my server. My
Yeah.
server is just command line arguments, but my client has a GUI.
That's okay too. You planning to make the server a GUI also?
I'm not sure about that.
Okay. Let's try something. Let's just make a pair of threads. Let's make a pair of threads and let's identify them. I'm going to have a thread 1 and a thread 2. And I'm going to construct.
Does the constructor need an int ID?
It does. Thank you. Thanks. All right, so I'll construct with an ID, and our run method. In fact, let's do it like this. Let's pass a scanner, so this is similar to something you're probably doing in your classes. Alright, so our thread, we're going to construct it with an integer ID to identify itself and a scanner to read from. And our run method is just gonna read from the scanner. Alright, so our run method is just going to loop as long as there's input coming in from the scanner. We'll print out this thread's ID, and we'll print out whatever that input is that's coming in. We'll construct our scanner on standard in, and we'll pass it to both of our threads. So what's going to happen when we run this? So we start putting input in through standard in. Is it going to work? Is it going to blow up? Is it going to do nothing? What are the possibilities here? Because this is a scenario that's probably kicking in at the end of your chat process when you try to shut down. If you don't shut down all the threads, you may have two threads running that are trying to read from standard in, right? One that's part of an active communication and one that's just kind of left over but doesn't know that it should be done. What are some of the possibilities here?
Scanner is really weird, so there's possibilities that you'll like just skip words.
It could just skip words. Scanner is weird. What are other possibilities?
Both still run?
Both still run. So I say hello and I hit enter. What do we think is going to get printed? Are they both going to print out hello, both threads?
Depends on which one has priority or is like currently being looked at, right?
Yeah, I don't think they're both going to input the same thing because the scanner is a single thing, right? It's constructed in the main class and it's passed to both threads, but SC here is the same as SC in the other thread. So when you try to read the next line, I think you only get one copy of it. And maybe thread 1 will print it out, maybe thread 2 will print it out. In some scenarios, they might alternate, or it might be totally random, as you said, based on whichever one happens to be running when the input comes available. Does anybody see a horrifying possibility? Not truly horrifying, but in the sense of an exception horrifying.
In the file?
Yeah, effectively, right? If thread 1 checks to see is there another line, yes, and thread 2 checks to see is there another line, yes, and now thread 1 calls next line to print it out, and now thread 2 calls next line, but there's not actually a next line available because there was, but it got absorbed by thread 1. Thread 2 might throw an exception.
It'd be a null pointer exception because SC is accessing a null value.
Yeah, or next line is at least.
That's what I got.
Yeah. So let's just see what this does. And I don't know if there's a moral to the story or not, but I've been curious about this anyway. All right, so we have two threads running out there, so let's just say hello. Well, yeah, that was pretty horrifying.
How are we getting an overflow?
Oh, that's what the exception I got.
Is it?
That looks like the exception.
Okay. We got a heap car buffer. That sounds good. So this is an exception that you get when, and it didn't print out any of the thread numbers. This is the exception you get when you try to do a next line and there's nothing available. When has next line didn't come back and return true, but you went ahead and did next line anyway. You get this buffer overflow. I don't know what buffer is overflowing, right? But I suspect that somewhere internally has next line, right, is somehow conditioning a buffer to ingest the next line of input, and it's not being properly conditioned. Something internal is overflowing. You can go to the source code for the different pieces of Java, right? You can go to the source code for scanner down at line 882 or 1796 and see what's actually going on in the code, right?
Maybe it's because it's the last one called as heap character buffer.
Mm-hmm.
I wonder if it's thinking that like the way they dealt with it is they made an overflow heap character buffers, like treated like not a number, but they also treated not a number like null. And so when
Oh,
they
maybe.
not a null, they look at it as if it's the same thing as not a number.
That'd be
They just
interesting.
overflow.
Wonder if my doc thing is good enough to do heap car buffer. Nope. That's deeper in the documentation. So I got better exception there. Got an index out of bounds exception. After a bunch of regex stuff, including character property greedy.match. So there's weird stuff going on in here, right? I actually didn't expect it to be this pathological. Let's make sure we don't have a red herring here. Let's just do one thread. Alright, so one thread works fine. So it's definitely the second thread.
Isn't the fix for this to give our threads a talking stick?
Yes. I don't know if we can synchronize run. Yeah. Alright, so now they're synchronized, so. And they're going to move alternating because as soon as one is reading them, the other one has certainly gotten to the top of the while loop and is being blocked. Oh, that's weird though, that I synchronized the whole run method. That shouldn't be working. That was an end of file. That shouldn't have worked.
Maybe it's because of how SC.has next line works, some scanner weirdness.
Yeah, if I synchronize run, the run method should only be running in one thread at a time, I believe.
But this dot SC equals SC, when you pull that thread out, what that's doing is, even though there's two separate instances of scanners coming from the same scanner, so they share the same assembly line,
Right.
conveyor belt. So I think that maybe that's why it's working.
Well, I could synchronize on SC, and that would definitely work because they'd be using the same talking stick. But it's very weird that synchronized works on the whole method run. Okay, there's something deeper going on there. But anyway, so that may be something like what's going on is you have an old remnant of the old chat still running, and they're both trying to read from the same scanner.
I'm gonna see if I can figure that out.
Okay.
It may end up being that I have to actually show the problem.
Okay. Yeah, we got Open Lab tomorrow, and I may do Open Lab Friday. I'm going to decide on Thursday, depending on how many people come in on Thursday. I may make Friday. So you already seen that I extended the assignment till Monday, right? So we might take Friday to work on it too. But I'll post a note Thursday. When you're writing this code, right, you've got multiple threads, you've got a client and a server. It's really helpful to try to be as descriptive as possible in your output. When you go into a catch block, right, don't just, print out a message like error, right? Print out a message that says, inside client thread number 2, read from server, or whatever your code is called, right? Colon, and then print out the exception. Because you don't want to just ignore exceptions. You don't want to just return automatically when you get an exception. You really want to understand where these exceptions are coming from. And one of the dangers with try-catch blocks is you can just throw it around your whole code, and if anything goes wrong, you jump down to the catch. And yeah, it stops you from seeing the word exception, but it can hide some useful information, right? So if you make your try-catch blocks as small as possible, just try the smallest set of statements that you can, and in the catch block, print out what the try block was trying to do, right? Got an exception while trying to read from SC in thread 2, right? And then print out the exception. And that can help you be more nuanced and deliberate in saying, okay, so here I'm going to close the socket, or here I'm just going to return, or here I'm going to ignore the exception and go back to the top of my loop, right? Because you've got multiple things going on, and it's easier to sort of know what's causing what. All right, any other PA5 discussion?
Actually, I have a quick question.
Yeah.
I notice in IntelliJ sometimes with the print writer, and I believe the scanner too, it makes me have to initialize them to null.
Possibly.
I do that and it fixes it, but I don't really understand why I'm doing that.
So,
I think it's because IntelliJ has the option of like customizable initializations, and so it's not guaranteed that something gets initialized as null. And for certain things, I would print out an exception for that. It gets mad.
that might be part of it. So here's a program. Let me do this. So let's make a scanner on a file. I don't really need this code. Okay, so this should give me an error about, oh man, getting errors that I wasn't planning on. Okay, so there's the error saying we've got a possible exception. We need to make a try-catch block. All right, so which line did it point to? The new scanner. Okay. I don't know if this is what's going on or not. Alright, so we put the scanner in a try-catch block, and this doesn't come up with IntelliJ, but if you do this by hand, you get these errors that it can't find SC because they're local to the try block now. So declare those outside and just set your scanner equal to, right? So now you compile it and it says may not have been initialized. Right. And so you set that equal to null, and it seems to be happy. But
that sounds inherently dangerous.
it's a band-aid, right? It makes the error go away so that you can compile and run, and it may not do any harm. But why does it think scanner might not be initialized if I write this?
Because that just declares as a scanner variable.
Okay, that statement just declares a scanner variable. So far at that point, SC does not have a value. Do I give SC a value anywhere? Yeah, in the try block, I clearly give it a value, right? So why is it complaining down at the while statement that SC may not have a value?
Because it's in the try.
Yeah, because that assignment statement could fail, which is why it's in the try. So if the SC equals new scanner, if that does not succeed, SC does not have a value, I jump down to the catch block, I print out ha, and then I try to use SC to read the next line, right? And it's warning me, hey, at that point, SC might not have been assigned a value. Now, if I say scanner SC equals null, right, that stops the error message from coming. But now when I run it, I get an exception, right? In reality, this is a warning to me that I'm doing something or not doing something, right? In this case, in my catch block, I probably want to say, you know, return. And now if I get an exception, it'll do the catch block and then just silently return. So if you're having IntelliJ or Eclipse create try catch blocks for you, it's not going to notice that, right? It's not going to necessarily put in that return statement. And that may be why you need to initialize it manually.
It might be. That's probably what it is, because I've gone back and noticed that I always forget that return
Okay.
statement.
Yeah.
I was going back and edit that, so that might be what it is.
Okay.
And I was saying, and that would make sense, because after I initialize them, sometimes I've noticed that then it'll say that this is redundant.
Oh, yeah, yeah.
So that might be what it was.
Mm-hmm. Okay.
So when we like construct a new object, and it's got all these variables, if our constructor doesn't explicitly tell those variables what to be, if those variables are not a primitive, they're automatically set to null.
I believe so, yeah.
If something's an object, and in the constructor of that object, or as some variable that is also an object that's not constructed or explicitly declared, is automatically set to null.
Mm-hmm.
So then why do we have to add null to get rid of that error anyway?
Because we're not constructing an object here.
Because it's the main.
It's the main, it's a static.
But if it was on a different file, the compiler still want, IntelliJ, if we created a new class, it would still want that because it doesn't know whether or not it's a static or not.
Well, so if we did this, so let's get rid of this first. Let's get our error message back. I don't know if that makes a difference or not. Ooh, oh, I'm in a static.
That makes quite a difference.
Let's forget about statics, forget that this is a main program. Alright, so that works fine.
Okay.
Right, so class variables will get initialized.
Right.
Right.
It's a non-static class.
But we're not actually constructing a class M2, right? The JVM is well, the problem is we had this down here. It's not a class variable, right? It's a variable inside a method.
Mm-hmm.
And those have got to be given values explicitly.
Okay.
But as far as I know, if it's defined outside of your method, so it's a field in the class, right, that those default to null and integers default to 0 and so on.
Mm-hmm. That's what I've been confused about when I get those. This like, why do I have to add the null to it already in that?
Right, so it's fine with all of those. But don't make your fields class fields just to get rid of having to say equals null. Right, the only things you want up here are things that really belong to the class. Things that after you construct the object, you really want these values to persist and you want them to be carried around as part of the object. So you never want to put like a temporary up here or something. Right. I'll come back to this code next year and be like, what the heck was this doing?
So I've got like a class in my SLP.
Mhm.
All it is just a bunch of variables to be accessed by multiple threads.
Yeah,
And just setters and getters and nothing else. Is that like
That's cool.
ugly, or is that okay?
I think that's cool.
Because like when I was constructing it, my architecture kind of thought like all these variables that everything has to access is like a central pillar. And so I wanted to be like equal distance from all of them. So that
Yeah,
everything-
yeah. No, I mean, this is like what we do with structures in C. It's really just a collection of different types of data bundled together, and sometimes there's a use for that even in Java. We don't necessarily need a bunch of code to manipulate that. If I was doing that and I had a lot of fields in there, right, my inclination would probably be just to make them all public, not even bother with setters and getters. Someone's probably like blaming me right now on Stack Overflow for saying that. But, you know, if it makes sense to you, it's just holding a bunch of data.
Setters and getters, because when I worked in my pull request,
Mm-hmm.
I wouldn't have been able to find anything.
Yeah,
I wouldn't
yeah.
have known where anything came from.
Right, right.
You set and get.
Mm-hmm.
Yeah.
Yeah. No, that's kosher.
Okay. What's the equivalent of like a global for Java?
So in a class, right, you can have fields and they're global to all of that. If you want something really, really, really global, probably a static field,
Okay.
right? So if you have a field like, you know, a class like globals, and you make a static variable in there, then any piece of code anywhere can say globals dot variable name, and there's one copy of that variable, right? This was what we did with your funny recursion, I think. We were doing globals. Yeah, there's basically one integer I, right, in the class globals if it's declared static, and so anybody can touch that, and it's shared by everybody.
But we should try and avoid that.
You know, so if you're writing code for yourself, anything goes, okay? If you're writing code for a large entity, whatever they say goes. In between, it's kind of like, you gotta figure out what makes the most sense, really. If it's going to be a horrible layer of complication to start passing something around to every single class, right, and every method and so on, maybe some kind of global makes more sense. If it's truly a global, right, maybe you don't want to have to pass it around. Maybe you never want this method to deal with a value other than, you know, this one, which is the pristine global that every method is using. It might actually make more sense to use a global. I don't think there's any, you know, true golden rules for Java or programming. But everybody's different. Some teachers will like hammer you for globals. Just an example. That's too long to go through. If you saw my talk back in September when I was talking about my processing system called Exist, and I showed a short video about this virtual ecosystem I had where there were these organisms moving around and they were eating food and attacking one another, and they were each being controlled by an instance of this Exist architecture, right? And this was all written in Java. And I was trying to evolve behaviors in these organisms. The framework for driving these organisms, for doing the simulation and so on, that was something I'd been developing for a year already. That was like Java code. But I wanted to throw this virtual ecosystem, this grid with creatures that could move around and so on and so forth. And I didn't want to rip apart all of this code that I've been developing for a year just to add in all these graphical elements and so on and so forth. This is a classic example where a client-server model can come into play, right? So I made a server. So this is virtual ecosystem.jar. I made a server that brings up a grid. This is the universe. And it's got scroll bars and good stuff like that. It asks for a port number, right? So randomly you just do port 1217 and you can say start. And this creates a server that listens on port 1217 and will accept a series of commands that I just kind of like specified. So R will reset the universe model, Q will quit, E will deposit some food somewhere, C creates a creature, and it returns the creature's ID. You can give an ID and say L or R to turn left or right, to move forward. You can get a query of what's near that creature, and so on and so forth. And this let me write code that basically just created strings, right? If the processor said this organism should move forward, it just creates a string with the ID of the organism followed by an F, and it shoves it out to the server, right, through a socket connection. So if we go to 1217, right, we've got a connection to this virtual world now, and up here it says connected to, localhost 127.0.0.1. But I could run this on different machines also, so I could run the CPU heavy code on a fast machine and then just put this on a separate display that I wanted to monitor or record or something. So you can do an E to create little energy pellets, right, pieces of food. You can create creatures, and when you send a C command, it sends back the ID of the creature. So that's creature 1, creature 2, creature 3, and so on. And then we can say 3 should turn left, and so that one up there turned left, and we can go forward. Right, and then if 3 is next to another creature and you try to move forward, it's an attack move, and it absorbs energy from it. So it's absorbing energy from creature 1, which has 103 units of energy available. And so we can drive that down. And creature 3 is getting more energy. Okay, so 1 is down to 7 units of energy, and so 1 just died, and so the server sends back this message K1, which means creature 1 just got killed. So all of these details of moving, bumping up your energy when you eat food, losing energy when you move, attacking, mating, all these kind of things are handled by the server, right? And the code that I was trying to develop, which was trying to drive these things in a way that makes them survive better, was completely oblivious to those mechanics, right? So this is like an abstract data type all over again. This is encapsulation and information hiding. The code I was writing that would send these commands knows nothing about what's going on over there, right? And that was the goal, was to see if you could simply, by moving around and trying to survive and being attacked and so on, if you could learn how to increase your longevity and pass that on to your offspring. Without knowing, when I move forward, I lose this much energy and so on and so forth. So it creates this separation of functions, and this is something that you see with client-server models. Client is trying to do one set of things, server is trying to do a different set of things, and you really don't want to mix those together. So you make this connection through a socket or a series of sockets, and now this side can worry about these things, and that side can worry about those things. So it's a really useful model in a lot of situations. I had another system where I was trying to do a lunar landing game, right? And lunar lander, you got a ship falling and it's accelerating under gravity, but you can turn on the thrust and that counteracts the acceleration due to gravity, but it uses up fuel, right? All those mechanics, that's part of the server side. Client side is just, it's you sitting at the video game, turn left, turn right, hit thrust, take off thrust, right? So separation of behaviors, abstract data types. All right, so the URL class. So we got some web pages using sockets going to port 80 on machines the other day. URL is a class of objects that is way more powerful. And knows how to do a lot of the things that web pages are capable of. So we can construct a URL with a protocol string, right? So HTTP : blah blah blah. And we can do things like get content to read what that URL returns. And we can open a connection, for pulling in information and a variety of other things. So I've got some code here. I'm going to open up, I'm going to construct a URL with the string http clark.edu, and that gives me a URL object. So URL I'm going to call the OpenStream method. That's going to give me something that I can use to construct what's called an input stream reader, which is one of the things I can use to construct a scanner. Okay, so this should create a scanner SC that I can use to read whatever is coming back after I open up that web page, basically. And so our usual while loop, while there's more stuff in the scanner, grab the next line, print it out. And then we close the scanner at the end. So that's the whole program, right? But if we compile this and run this, right, it gives us a whole bunch of output. So run this through more. So the beginning tags are, you know, HTML markup, and there's an old emergency notice from February. Clark College will be open for classes and activities on Thursday. I don't know why that's still in there. But if you come down here, there's, you know, welcome to the Penguin Nation, Clark College in Vancouver, Washington. So this is pulling off a web page, right, and showing us the contents of it. And it's pretty painless. And there's a lot more to, you know, a really good web browser, to know what to do with all of this stuff. Anybody ever play with links? Lunks. So Lynx is a command line based web browser. This is before Netscape was around. And it still kind of works, you know, so you can arrow key down. And let's look at registration. This is going to be horrifying. Let's look at programs in degrees. So you hit enter, and yeah, there you go. It doesn't work very well. So this works really well on like straight HTML, probably not so well on fancier pages doing PHP and things like that. But you know, you could write something like this in Java or C, just using the URL class and doing some formatting on your output. But we can actually do a lot better than that too. We only got 10 minutes, so I'm going to get some old code and just resurrect it. Alright, so got a J-frame as usual. I've got my content pane as usual. I've got a go button. And then here I've created what's called a scroll pane. And a scroll pane is something you can put something else inside of, and if it exceeds the bounds of that pane, you get scroll bars on the side. It kind of adds them for free. And inside the scroll pane, I'm putting a web pane, right, which is actually an object of type JEditor pane. And JEditor pane is really, really powerful. So JEditor pane has one method in particular called SetPage. And you can set page with a URL or a string. And lots of words here, but the punchline is it will basically take the content that comes from that page and display it inside this text field. And it's kind of like a method in a class that gives us a web browser. So let's look at our Go button. So our Go button is going to construct a URL. It's going to use astronomy picture of the day from NASA, which is a cool website. And then web pane, which is our JEditor pane, is going to use the SetPage method, and it's going to give it that URL. And then it's going to set editable to false, and there's a reason for that. Well, let's not do that first. Alright, so let's run this. And let's say go. And there's the astronomy picture of the day. Right, and it's scrollable. And so there's, you know, the description of it, and so on and so forth. And I can point to these links, and my cursor changes shape, but oh, it's already doing something. Oh, never mind. Yeah, okay. So it's doing more that I haven't shown you yet. Okay, so SetPage URL loads the URL into that page. So what I also already added into this was an event handler. So event handler, there's a class called Hyperlink, and there's a Hyperlink update. Okay, and I've already put some code in there. So Hyperlink update will get called any time that you move over a hyperlink or click on a hyperlink. So let's go in Hyperlink update, and let's just say let's just print out the word hyperlink plus whatever that arg0 is. And if we run this and we load up our page, right, anytime I come over a clickable link, I get information, including the picture, right? And so it's got information about where I am on the page and so on and so forth, but it also includes a URL. So I can do arg0 get URL, and that'll give me back the URL corresponding to that link. Okay, there's also a method getEventType that I can use on that argument, which tells me what kind of event just happened. And there's an entered when you point to something, an exited when you leave it, or an activated when you click it. So what I'm doing in here is when you do something with a link, we'll come into this hyperlink listeners method, hyperlink update, and we'll say if the type of the event is activated, meaning you've clicked on it, okay, I'm going to print out a message which says click, and I'm going to print out the URL. So let me get rid of this bogus print up here. And then we're just going to do a SetPage with that URL that we got. So that's enough to let us follow links. So here's the original image, and if we click on long exposure image, right, you can see what page we just clicked on down there, astrobin.com, and here's what astrobin.com is. And we can click on home, and that takes us home, and about.
This could easily be modified to create a mini browser.
Yeah. I mean, we've already got a crude browser of sorts here. So, suppose we wanted to add a back button. So we could go, because I can't go back right now. I can just go back to the beginning by hitting go.
You would have to save the last URL somewhere.
Okay, save the last URL somewhere, and then when you hit back, pull that up and load that into your page. What if you want to go back a second time?
It's a combination of PA4 and Hyperlink.
Yeah. So what kind of structure will we use to save all these pages?
Decision tree.
Linked list.
Maybe. There's a best answer here. two linked lists.
Is it a red black tree?
It's a stack, right? Why is it a stack? Because the nature of the back button is the last page that you saw is the first page you want to go back to. It's a last in, first out. That's a stack. So every time you go to a page, push it on the stack. Every time you hit the back button, pop the top of the stack, load that page in. What happens when the stack's empty and you try to pop? There's no page to go back to because you're looking at the first page. So every time you pop, if the stack's empty, gray out that back button. When you push something on the stack, make the back button available now. All right? This is all that our technological, computerized world is. It's just a bunch of code, right? And it's built on top of data structures that you already know, right, and understand and can use. And this is what all this stuff is, right? It's no more than this, right? It's built on top of layers, and it's incredibly complex. But the building blocks are things that we already understand and know, right? Java is just a bunch of C code, right? JVM is written in C. If you can write C, you can write Java, and then you can do all the stuff that Java does, right? And if you want to go down the other direction, right, C is just running on a bunch of assembly language instructions. And you learn that with a PIC, and those are doing what they do just because they're sitting on top of a state machine called the PIC processor, or the Intel x86 or whatever, right? So you've got like a huge amount of the modern world in your hands and your brains, which is cool. All right, so so tomorrow's open lab. I'll post a note tomorrow about whether Friday's open lab or we're going to do something else. I'd like to go on and show you how to use jar files in Eclipse to pull in other packages like speech modules, things like that. Monday we'll start project presentations, and then we'll just wrap up end of next week. So come tomorrow, please, 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 if you're having trouble with PA5 or you've got questions about it, come on in, either both section or office hours, and let's go through your code and see what's going on.